today what we're going to do is we are going to take what we did in the last video, which was factoring expressions that looked like this without an equal 0 on the end. We started with doing a times c. We used that big X method to keep us organized if we wanted to. We rewrote this as 4 terms and factored by grouping, and we stopped there. However, when we have an equal 0, that means we could potentially solve, and that's what we're going to do today. All of these are factorable and can be solved. Not tricking you, I promise. So the factoring is exactly what we did in the last lesson. We're not going to worry about this equals 0 till after we're completely done with the factoring, but I would strongly recommend that as you do each step, you keep that equal 0 there so you don't forget that, oh yeah, I still need to solve. So I may go a little faster than I did in the last video with the factoring part. Feel free to pause as you need to, but since you already know how to do the factoring, I'm going to focus more on what you do after that. So just like in the last video, if you'd like, start by labeling A, B, and C. In this problem, A times C is going to be 1 times -10, which is -10. Just like in the last video. If you'd like to write this X out and you organize yourself that way, you can, don't have to. This is not technically part of your answer, but it can just help you keep yourself organized. Since A times C is -10, I'll be looking for 2 numbers that multiply to -10, but add up to my B number, which is -3. So thinking about how I can get to 10 by multiplying. I can do 1 times 10, I can do 2 times 5. The only way I can get one of these sets of numbers to add up to -3 is if I use 2 and 5, +2 and -5, because 2 minus 5 is -3. So now I rewrite this as 4 terms before the equal sign instead of 3 terms. N squared stays the same. Remember that instead of the middle term, we split it into these 2 numbers. So instead of -3n, it's going to be +2n minus 5n. Or you can do -5n plus 2n. Order's not super important. The -10 stays the same, equal 0 stays the same. We're just going to keep that equal 0 along for the ride until we're ready for it. Now let's do our factoring by grouping. GCF of the first part is just n. N squared divided by n is n. 2n divided by n is 2. For the second half, it's going to be a negative GCF, and it's going to be a -5. -5n divided by -5 is +n. -10 divided by -5 is +2. Keep the equal 0 along for the ride. Now, do I have the same thing in both sets of parentheses? Yes, that means our factoring has worked out so far so good. Regroup it into 2 sets of parentheses. N minus 5 goes in one set. Repeated n plus 2 goes in the other. If we didn't have this equal 0, we would stop here. Our final answer would be those 2 sets of parentheses. However, like we've done in the past, if we have an equal 0, that means we can solve. Sort of like we did back when we did GCF factoring and solving, I'm just going to take each of these parts and set it equal to 0. Let me show you exactly what I mean. So I'm going to do n minus 5 equals 0. And I'm going to do n plus 2 equals 0. And then I just solve each of these small equations. And if you can solve this without showing work, fine. You do not need to show this +5 step. Because I know it's a 1-step equation. You probably don't need to show work for that. So my first solution is n equals 5. To solve the other equation, I get n equals -2. Again, if you wanted to skip that green step of work, you could. So, you're probably thinking, Mrs. Avers, there's a lot of stuff on the board for just one problem. What do you really need to see? So, I don't need to see this big X. If you would like to, I definitely need to see how you regroup it. I definitely need to see what it turns into. And I definitely need to see your answers. Other stuff in between are optional, but I at least need to see these 3 parts here. If you would like to show every single step at work, cool. If you want to include this, cool. Whatever works for your brain is what you need to do. Let's keep trucking. Next problem. A, B, and C. A times C is going to be 3 times 2, which is 6. So we're looking looking for numbers that multiply together to 6, but add up to our B number, which is -5. So, how can I get to 6 by multiplying? I can do 1 times 6. I can do 2 times 3. This particular set of numbers throws people off. So I need to get it to a -5 by adding. So you might be thinking +1 and -6, which works, but if I do +1 times -6, I get -6. I need a +6. So the only way I can get a positive number by multiplying, but a negative number by adding, is if I have 2 negatives. -2 times -3 is +6. -2 plus -3 is -5. So my two numbers are -2 and -3. Rewrite this left-hand side as 4 terms. So 3r squared stays the same, minus 2r minus 3r, plus 2 stays the same, equals 0 stays the same. Factor it by grouping. GCF, the first part is just r. When we divide by r, we get 3r minus 2. Second half, we have a negative here, so it's going to be a negative GCF. The only number I can divide both 3 and 2 by is 1, but since I need it to be a negative GCF, it's -1. No r here because there's no r in the +2. When I divide by -1, I get positive 3r and -2. Regroup it. So r minus 1 goes in one set of parentheses. Repeated 3r minus 2 goes in the other. Now I make my two equations and solve them. So I do r minus 1 equals 0. I do 3r minus 2 equals 0. And I solve them both. You don't have to show this step of work here, but I'm doing it just so you know where things are coming from. First solution is r equals 1. Second solution will be a fraction, and that is okay. Or you can write it as a decimal to your editor. So I add 2, and then I divide by 3. So I get 2/3 or 0.6 repeating if you're a decimal person. So again, it's like we've done with our factoring, we're just adding on that solving step. We can't solve until we get it factored. Once we have it factored, we set each part equal to 0 and solve the small, easy equations we get from there. I'm going to do 2 more just so you see 2 more examples. Again, feel free to pause because I'm going to go a little quickly here because we've done a lot of factoring already. All that's new is we're just adding on the solving. Next problem, A is a hidden 1, B is 11, C is 24. So A times C is 1 times 24, which is 24. I need 2 numbers that multiply to give me 24, but add up to my B number, which is 11. I wanted that to be a plus sign. So, how can we get to 24 by multiplying? I can do 1 times 24, 2 times 12, 3 times 8, 4 times 6. The only pair of numbers that will get me to add up to 11 is 3 and 8. Everything is positive here, so it's going to be 2 positive numbers, positive 3 and positive 8. So I'm going to rewrite this as x squared plus 3x plus 8x plus 24 equals 0. GCF of the first part is just x. When I factor out x, I get x plus 3. GCF of the second half is just 8. When I divide by 8, I get x plus 3. These match, so I'm good. I just need to rewrite this as 2 trinomials. First one is x plus 8. The other one is x plus 3. We have an equal 0, which means we need to try and solve this. So we're going to solve x plus 8 equals 0 and x plus 3 equals 0. To solve, oh, this red marker has seen better days. Okay, different red marker. Subtract 8, I get x equals -8. To solve this one, subtract 3, and I get x equals -3. One last one, and we'll call it a day for this video at least. So this time A is 8, B is 11, C is 10. A times C is going to be 8 times negative 10, which is negative 80. So I'm looking for two numbers that multiply to negative 80, but add up to my b number, which is 11. So how can we get to 80 by multiplying? 1 and 80, 2 times 40, 4 times 20, 5 times 16, 8 times 10. Those are my options. Since it's a negative 80, to get a negative by multiplying, I need one positive number and one negative number. The only way I can get to a positive 11 is if I make it a negative 5 and a positive 16. Negative 5 plus 16 is 11. Negative 5 times 16 is negative 80. So I'm going to rewrite this as 8m squared minus 5m plus 16m minus 10 equals 0. And friendly reminder, I talked about this in the last video. If you switch the order of the negative 5m and the 16m, your work in the middle might look a little different, but your answer should still be the same. Fact by grouping. So, GCF of the first part is just m. 8m squared divided by m is 8m. Negative 5m divided by m is negative 5. Second part, GCF of 16 and 10 is 2. Positive because it's a plus sign in front of that 16 then. 16m divided by 2 is 8m. Negative 10 divided by 2 is negative 5. These match, so I'm golden. I'm going to rewrite that as m plus 2, the two GCFs, and then the repeated factor 8m minus 5. We have an equal 0, means we still need to solve. So my two equations are m plus 2 equals 0, 8m minus 5 equals 0. Solve them both. Again, you can skip showing some work here if you like. First solution is negative 2. The second one's going to be a fraction, that is okay. We add 5 and divide by 8, and we get 5 over 8 for our answer there. So, combines a lot of things we've done already. Remember that when we are solving by factoring, we need to do all of our factoring first and then do our solving. Feel free to skip some steps here and there with the work. This is the bare minimum of what I want to see, but you can show as much as you need to. That's it for today. Have a great day.